Right. This is the March 2015 Maths Common Test, Grade 11 National Senior Certificate. It's only 1.5 hours, 75 marks. It's probably not that difficult. Gonna go through it, gonna try and be as careful as possible. So I'll just be writing here on the right and all the questions on the left. So question, I guess I need to write much cleaner. Question 1. 1.1 says simplify fully. That's important. Simplify fully. It'll take me much longer than 1.5 hours just because I'm not used to writing on a computer. Simplify fully means do all the operations according to BODMAS. You can't really overstate how important it is to actually read what they want from you. Don't always assume it's obvious. Okay, 1.1.1. 1 over 729 raised to minus 2 over 3. 1 over 729 raised to minus 2 over 3. So the first thing we can do is we see, remember your BODMAS. So we see this exponentiation and there's a negative exponents. In maths, we don't use negative exponents. We take the reciprocal, 729, which you can write as 729 over 1. So this negative, we take the reciprocal here, 2 over 3. Make sense? So if you had a raised to minus 1, you write that as 1 over a. If you had a raised to minus x, you have 1 over a raised to x. That's how we deal with negative exponents. Okay, so having done that, now we say, okay, we got 729 raised to 2 over 3. Well, we have a fractional exponent here. So this is probably some power. What power could this possibly be? Why do I want it to be a power? Because if we can write this as a power, if this is x raised to something, x raised to a, the whole raised to 2 over 3. If we can write this as x raised to a, then we can say this is x raised to a times 2 over 3. And hopefully this is something much simpler. The a and the 3 can cancel. And hopefully this number is much easier. So that's why you need to ask, can this be written as a power? Okay, so can it be written as a power? Well, it's probably a power of 3. Why? Because all multiples of 3 have the number 9 in it. So we know 3 raised to 1 is 3. 3 raised to 4 is 81. So what is 81 times 3? Well, it's not 729, definitely. How do I know that? I don't really need to know what 81 times 3 is. I just need to know that the last digit is going to be 3. So it's not 3 raised to 5. 3 raised to 4 is 81. 3 raised to 5, whatever it is, ends in a 3. So maybe it's 3 raised to 6. So maybe it's 81 times 3 times 3, which is 9. So 3 raised to 6 is 81 times 9. 9 times 8 gives me 72. Yes, it is. So 3 raised to 6 is 729. If I was still in high school, I would know this. But some of these things you forget and you have to. So this can be written as 3 raised to 6, the whole raised to 2 over 3, which can be written as 3 raised to 6 times 2 over 3. 6 and 3 cancel. It's 1, that's 2. 2 times 2 is 4. 3 raised to 4 is 81. Done. Okay. Nope, I don't know how to scroll on this thing. Should be easier. Okay. 1.1.2. 5 raised to 2 minus m times 10 raised to m, the whole raised to 2, the whole over 2 to the m minus 1. Again, they said simplify. They didn't say solve. So don't think, oh, I need to find m, because there's no equation here. They just want this in its simplest form. So this looks like a minus. It's actually a multiply. Even write that, actually. All right, so again, simplify just means use your normal algebraic laws and don't forget to use BODMAS. So one thing I'd like to do is I'd like to get everything to the power m together and everything which is a constant together. But first I'm going to deal with this quotient. So I don't want this in the denominator. I want it in the numerator. So I'm going to write 5 raised to 2 minus m, 10 raised to m. So if a to the minus x is equal to 1 over a, the whole raised to x, you can also do it other way around. If you don't want this in the denominator, you give it a negative exponent. So instead we'll say 2 to the m minus 1, the whole raised to minus 1. That's the same as having 2 to the m minus 1 in the denominator. Alright, so now we're going to simplify this out. This gives me 5 squared times 5 to the minus m times 10 to the m times 2 to the m times minus 1 is 2 to the minus m times 2 to the minus 1 times minus 1 is 2 to the 1. So 5 squared is 25 times 2 gives me 10. So 250. That's my constants. And okay, so that's my constant 250. Now for this to the m, what you can do is you can write this as 5 to the minus 1 times 10 times 2 to the minus 1 all to the m. Why? Because if you use your power rule backwards, you get 5 to the m, 5 to the minus m, because it's 5 to the minus 1 times m, minus 1 times m, 10 to the 1 times m, 2 to the minus 1 times m. That gives you everything we had up here. So if you simplify that, you can get 250 times 5 to the minus 1 is 1 over 5. 2 to the minus 1 is 1 over 2. 10 to the 1 is 10. So we have 1 over 5 times 10, which is 2, times 1 over 2, which is 1. So 1 to the m. And we know that anything raised to m, 1 raised to anything is 1. So we have 250. Done. Seems complicated at first, but all you have to do is be logical and take it step by step, and everything kind of just works out at the end. 1.1.3. This is 5 times 2 to the y plus 1 minus 2 to the y, the whole over 2 to the y minus 1. So what are we saying? We're saying 5 times 2 to the y plus 1, right? Minus 2 to the y. And then we have 2 to the y minus 1. What I would like is to have the term 2 to the y as its own thing, right? Anytime you see this kind of thing here, y plus 1, you should see that as 2 to the y times 2. Why? Because then you can get rid of this plus 1, because this is actually times another 2. You're basically saying 2 is multiplied together y times, and then times by 2. Why don't we bring that 2 out and make it part of the coefficient? So we can go 5 times 2 times 2 to the y minus 2 to the y over 2 times 2 to the y. Okay, so now we have 10 times 2 to the y minus 2 to the y, the whole divided by 2 times 2 to the y. Well, imagine this was x instead of 2 to the y. You'd have 10x minus x, the whole over 2x. What could we do? Well, we can just simplify it in the numerator and the denominator. We can go, well, I have 10 apples minus 1 apple, if an apple is 2 to the y. So 10 minus 1 gives me 9. I have 9 2y's. It says I have 10 2y's minus 1 2y over 2 2y's. So if you're confused, you can actually say let 2y be equal to k, just so you can see it clearer. And you can say I have 9k divided by 2k. Well, what happens? K and k cancel. So my answer is 9 over 2. And you may be tempted to simplify this to a decimal, but don't do that. Civilized people don't use decimals. Okay, 1.2. See, now this is not a simplified question. This is a show that question. Very different. Why? You already know what the answer is. The answer is exactly the equation that's been given. So don't take the equation and try to solve the equation or simplify something. You take one side of the equation alone. So you say left-hand side is equal to 9 minus root 54, the whole over 6 root 2. And you say, can I turn that into what I have on the right? Can I turn that into what I have on the right? Well, look at what you have on the right. You have a root 2 and you have a root 3. So those are very simple forms, right? We call them SIDs, when you have the root of something that you can't take the root of. Root 4 is 2, so you'd only simplify that. But root 3? 3 doesn't have a square root, a rational square, an integer square root. So we usually just leave it as root 3. So what we need to do is we need to simplify this root 54, basically, because that's the part that's not simple. So this can be written as 9 minus root of, what's 54? 54 is 2 times 27, right? So 2 times 27. 27 can be written as 3 times 9. So we have 2 times 3 times 9, all under the root sign, the whole divided by 6 over root 2. Well, then we have 9 minus root of ABC is the same as root of A times root of B times root of C. So root of 2 is root 2. Root of 3 is root 3. Root of 9 is actually an integer, it's 3. So we can write that as 3 times root of 2 times root of 3, the whole divided by 6 root 2. At this point, you may be tempted to say, let's cancel the root 2 and the root 2, but you can never cancel from a sum, and the numerator is a sum. So don't give in to that temptation, no matter how powerful it is. Don't do that. But what can we do? We want to cancel. We want to get rid of something. You can never cancel from a sum. You can only cancel from a product. So can we turn what's in the numerator as sum into a product? If you want to turn a sum into a product, you factorize. What can be factorized here? Is there a common factor? Yes, there is, 3. So 3 times 9 becomes 3 minus this 3 was taken out when we factorized, root 2 times root 3. The whole divided by 6 over root 2. 3 and 6 cancel, giving me 2. Alright, we've simplified slightly. Are we any closer? Now, remember they didn't ask us to simplify. They asked us to get what's on the right-hand side, right? So we're not yet there. 3 minus root of 2, root of 3, to root 2. So you might be tempted to say, well, what can I do now? Can I cancel? Well, try to remember what your goal was originally. It's not to simplify this. If it was, we'd be done. We'd walk away because this is the simplest it can be. But what we're trying to do is complicated, actually, because we want to get to what's on the right-hand side. And we're close. What we have here is 3 root 2 minus 2 root 3 and over 4. And what we have is 3 minus root 2 root 3, the whole over 2 root 2. If you just focus on the denominator, what we want is a 4. What we have is a 2 root 2. To get 4, you need 2 times 2. We have 2 and root 2. We need another root 2 in the denominator to make it a 4. But remember, you can never add something to the denominator that you don't add to the numerator, because this isn't an equation, it's just an expression. So if we're going to add something if we're going to multiply in the denominator, we have to multiply in the numerator. So just note, I multiplied by root 2 in the numerator and in the denominator. I introduced it. Ultimately, it does nothing because I did the same thing in opposite ways, so that cancels. But what does it allow us to do? Well, 2 times root 2 times root 2 gives me 2 times 2, which is 4 in the denominator. And in the numerator, this root 2 goes 3 root 2 minus root 2 times root 3 times root 2. Root 2 and root 2 give me 2, root 3. Hey, but that's exactly what we had in the right-hand side. Okay.